Hi, welcome to my talk. It's called Yoke, an exploration into Kubernetes package management as code. It's a story from me, a platform engineer who wants to move beyond YAML for good. To start this, we have to start at the beginning. Kubernetes APIs and what I like to call the manifest conflation. What I mean by that is that we start very simply with a set of Kubernetes APIs for creating and managing resources. These can be our services, pods, deployments, ingresses. And how this works is that we send these resources in their entirety to Kubernetes, and Kubernetes figures out what to do. It either creates it calculates a diff, it applies it. And since we're working in this idempotent setting, it's easy for us to describe these resources statically in files in their entirety. And so what we do is we write these YAML manifests and we sync these with our Kubernetes clusters, which leads us to create this conflation that these APIs are just these YAML manifests. And when we talk about packages, we can define it as a set of manifests that together define our application, and that is a package. But we can't just define a static package. So we make configurable and reusable packages via templating, via the templating of these YAML manifests. And that's where we are today. So in a word, what we've described is Helm. Helm is the de facto solution for Kubernetes package management. But it's not without its issues. We don't have static typing. We manually need to maintain schema and values. Most projects forgo schemas within Helm. It's sensitive to typos and YAML indentation errors. There's no way to test it out of the box. It's difficult to derive new data from the inputs and the values that we give it. There's no documentation per se. You have to read the YAML, read the comments. Maybe somebody wrote some markdown on their repo's GitHub page. It's kind of like working in JavaScript in like 2014 before TypeScript arrived. And then you have this inconsistent experience between editors. In my experience, people say, well, if you want a good experience working with Helm, you have to get an IntelliJ product. But it's weird that we need to opt into these vendor locked-in spaces to be able to work with something as basic as packages for Kubernetes. And so how do we deal with these issues? How do we solve them? Well, the answer is always more tooling. Right? We build test frameworks like Helm unit test or test chart. We define schemas in various languages like Q or JSON schema, and we tack those onto our charts. For the chart navigation in our editors, we use IntelliJ plugins or VS Code Kubernetes plugin or others. I don't even know how to do that in Vim. So we can take a step back and say, well, why are we doing it in YAML? Why are we templating things? Is this really a good experience? And we realize that Kubernetes resources, they differ fundamentally from web pages, emails, and push notifications, and other types of user content that we might want to template or make generic. Resources are structured data, representing well-known APIs that are typed. And we know what the most effective tools for working with structured data are. It's programming languages. So we need to make a mental model shift. We need to go from values YAML files plus templates to manifests to an input and a function gives us Kubernetes resources. And from that model, we can start talking about packages as code. And advantages are that we get control flow, built-in testing, discoverable contracts with static typing, compiler errors, IntelliSense, documentation. package distribution. We don't need to create chart repositories. We have packaging and distribution and versioning already built into language ecosystems. We have Cargo for Rust, Go modules, NPM, pip, you name it. Right? We basically get everything that we didn't have before. So the tool I'm going to read about code packages is that packages should just simply be programs that can output Kubernetes resources. And we can share packages by sharing code. So why hasn't this been done before, right? If it's so obvious. Well, how do we, package code, and how are we going to run it? Should we send zips of code? Should we clone these repositories? How do we support different languages and architectures? What if it's a Ruby or Java or Go or Rust? How do we run those things? How do we know how to run those things? Which versions of those languages should we be running? And suppose we solve that problem. How can we run code securely? We don't want arbitrary code, like third-party dependencies that we have in our code, to do any operation, especially in the context where they could access our clusters. So how do we solve this? WebAssembly. Super promising. I think this is the solution to this problem. WebAssembly as a package format gives us a lot of benefits. It's a single target for multiple languages and ecosystems, and it's supported by most static languages like Go, Rust, Zig. You can write TypeScript via assembly script, and you can use Java or C# or you name it to describe your resources. And when you run WebAssembly, you get a sandbox runtime that doesn't have access to the file system or network. And you get a single asset that is easy to host, download, checksum, execute, basically everything you need. And of course, it's independent of OS architecture. Wherever you have WebAssembly, as long as you have an interpreter, you can run it. It doesn't have to be compiled for a specific OS. So now we get to Yoke, the experimental IAC package manager for Kubernetes. So what is Yoke? Yoke is my experiment. What it does is it executes WASM programs and creates releases from the output of those programs, tracking the revisions across time, just like Helm. It's basically Helm, but for WASM. In Yoke, packages are just programs that output Kubernetes resources, and we call them flights, where Helm has charts, Yoke has flights. Helm is the steering wheel of a ship, and Yoke is the steering stick of a plane. So we call them flights. So for the demo, I have a simple disclaimer that everything is going to be written in Go to take advantage of the Kubernetes ecosystem, and because that is what I'm most comfortable in. And so the demo, we're going to see a simple Yoke flight program, and we're going to show an Argo CD and Yoke integration. This is very pared down. There's a lot of things that I would have liked to show, such as compatibility with Helm ecosystem, because Helm is just a program, so we can run Helm to, if we want to create flights that use Helm. But we don't have time for that today. So let's start with these two things. So let's begin. Let's start with a very basic program. Right, here we are in a little project, and all we have is a main.go and go mod and go sum. And on the right, we just have a little K9 instance looking at a local kind cluster. And right now there's nothing in it. There's no pods. So we want to deploy whatever this file is. And for the purposes of this demo, it's going to be a deployment that just echoes out a message. So if we start looking at the basic stuff, we have a package main. It's a binary. It's a main program that's an executable. And then we can look at our dependencies, and we have normal dependencies like standard library stuff like OS, JSON, formatting. But then you can see that we actually have the Kubernetes client imports. And this is because we have access to all of the core types, core v1, meta v1, apps v1. It's already all available. We don't have to read YAML and figure out docs. We have everything we need already right now in our editor. So we run a main program, and here's our run definition. We have some values, very similar to to Helm, except that it's statically typed, right? With name, labels, replicas, the image we want to use, and the message. In this case, it's going to be hello platform con. And we can parse in inputs from standard in, just to show that we can make configurable programs, though there's an argument to be made that recompiling is more statically type safe, but let's leave that aside for now. And then we just encode to standard out our deployment, our echo deployment. So if we look at those values that we saw above, name, labels, replica, image, message, and we can see the function which creates that deployment, this deployment configuration. And you can see we have this typed API where we're using core v1 to create a container, which has our name and our image and this echo command, which will print out our message. We have the template spec and the deployment spec. And in the end of the day, we create a deployment. And obviously, this is a very simple and naive example, but you can create multiple resources, and functions can create everything it needs for the application. And if I wanted to edit this and create new things, everything would be very easy to do, right? I could come in here and say with an image pull policy, and I could figure out, well, okay, I need a value for this, and I could say it's a core v1 dot always. Let's see, yeah, v1. There we go. Pull always. So I can always, I can never get it wrong, right? Everything is easy to do. It is code. It's not YAML magic. You're not in the dark. So how do we use this? How do we use this program which outputs this JSON? Well, first we need to build it. So if we want to build it as WASM, we can build out this main.go as a main.wasm using WASI preview 1 and WASM architecture. If we do that, we should get a WASM file, main.wasm. We can use the yoke to up or install, or in this case, the language is takeoff. Give it a release name, just use example, and give it the main.wasm. And if we run this, we shall see that we've created these example programs, and they've been deployed to Kubernetes. So if we look inside, we'll see that we're logging hello platform.con, which is exactly what we wanted. And if we look inside Yoke, we can inspect, and we can see that we have an example release at revision ID 1. And we can see what that revision is. It is a flight from main.wasm with this checksum created at this time, which has one resource. If we want to run it again, we can take off and configure it. Let's pass in a file to it. And we can say, well, this time we want to say that the message is going to be demo time, and that we want replicas 5. And if we look over here, we'll see that we're creating these new replicas. And if we inspect example again, we'll see that we have 2 revisions of this example. And if we look at what's running, now we're saying demo time. So we're able to manage our package over time, just as if we're using Helm, except that this time we have all of the benefits of static typing. And we can build tests out of this. And if we wanted to make this not just a binary, we could put it in a library and share it and version it over time. We could compile this program and distribute the WASM as a GitHub release or any which way you'd want. So that's the basic idea. But next, what we should think about is that we don't always want to directly use Helm or something like Yoke to interact with our clusters directly. We want a more GitOps approach than just running these commands directly in the terminal. And so often we have tools like Flux or Argo CD to create these applications. And what's nice is that Argo lets you configure how you render your configs. So obviously Helm is a first class, has first class support, but we can build applications with plugins to say how we want our things to be rendered. So actually, I'll come back to this in a second. If we go to an Argo page, we can have our app of apps, right, with a manifest. And this manifest can point to a repo URL, some manifests, and just be a normal application. And under the hood, the applications that it renders can be Yoke applications, which point to a WASM file. So in this case, the manifest for this Hello World application in Argo is just a normal application, described in YAML, of course. But instead of pointing to some resource or describing some Helm chart, what we're saying is that when we call this application, use a plugin called Yoke CD, Yoke plus Argo CD, and look up some WASM files called main.wasm.gzip. And you can find it by looking up this repo URL at this revision along this path and this file name. And what it will do is it will create that application. Sorry, I want to go in. And what you can see is that it created this deployment and the replica set and the pods underneath. And all the resources are managed by Argo CD. They were just rendered by Yoke, which is just a Go program that embeds the WAS0 runtime, which is already in Go, and interprets WASM. And as a slightly more complicated example, we can have this Postgres.wasm, which isn't just a Postgres program, just a flight, a normal WASM program, but that renders a Bitnami Postgres chart. And you can deploy something as complicated as a chart using this approach. And that's basically it. We want to be able to say that what we want is a good developer experience. We want confidence in what we deploy. And we don't want to be fixing indentation errors and spelling mistakes and wondering if we've read the documentation right or if the documentation even is right. We want to use all the tools at our disposal from software engineering to be able to operate our clusters and describe the relationships between things. And that's the point of this experiment. And with that, I think my 15 minutes is up. So thank you very much, PlatformCon. And feel free to reach out to me if you have any questions. Thanks.